Well, Joe Postma, welcome to the Johnston Clan Telegram chat, mate. Thank you.
Thank you. Nice to be here.
Yeah, no, it's great. I've obviously been a fan of your work for a while, and we've had sort of private correspondence, for probably a couple of years now. Whenever I find someone's work, I always, especially yours, I had questions, and it's when the people come back to me with answers promptly and considered and all that sort of stuff, it's great because it shows me that they're kind of genuine, and so I've always enjoyed sort of our correspondence. Mate, obviously I've given the family members a bit of information about yourself and your links, so you can tell them a bit more about yourself, or you can just go into the presentation. Obviously we've got some questions that I'll ask afterwards that have been put into the chat, and we'll just go from there, mate.
Okay, sure. Well, as far as who I am and my credentials and whatnot, just so that they have an idea who they're talking to. Yeah, so I'm my name is Joseph, obviously Joe, from Canada. I work at the University of Calgary, and I'm staff there, and I work on a space telescope project with the Indian Space Agency, and the Canadian Space Agency is supporting that. And so I basically do the data processing. I wrote the data pipeline software for the telescope to reduce the images that you gather in space from the telescope. A lot of processing needs to happen to those to turn them into science quality images. So I was involved in this project right from very early on with it, not from the very start, but fairly early on with the development of the hardware electronics. I worked with the aerospace engineering companies, developing the electronics and help setting the standards and the calibration parameters so that this telescope and its electronics, detector electronics, would produce the level of the quality of science product that we required and that was intended. And so, so that's what I do now. And I have a degree in astrophysics. And, so I basically have a physics education. So I'm well versed in thermodynamic theory and, basic physics concepts and things like this. And as far as my relevance to climate alarm, I mean, anybody who has a degree in physics or astrophysics is qualified to discuss the science of climate alarmism, or climate science, if you want to call it climate science for now. I don't think it's much of a science, actually. It's not that difficult, the science. It's not that complex. Certainly everything we learn in astronomy to do with gases absorbing radiation. I mean, that's what astronomy is all about, gases absorbing radiation. So we know all about that sort of thing. Spectra and temperatures and radiation effects, all that sort of stuff. That's all par for the course for an astronomer. So it was very easy for me to look into the science of climate and to assess what they were doing with it, whether or not any of it made any sense at the foundational level. And so, what I found was really at the foundational level, it is really, really, really a flawed science right from the get-go. And it's so flawed that it's actually pseudoscience. The whole field is basically a pseudoscientific field of political science. It's really a political science. It's really a social science in the sense of psychology. It's a psychological science, really, of how do you do all the non-scientific things and pretend to be science, right? How do you appeal to authority? How do you ridicule people who think differently from you? How do you railroad people who have alternative concepts out of the debate? Everything that is anti-scientific is basically what climate science is the exploration of, to see how far they can go with it. And they can go the full way with it. In fact, they can go completely the full way and get everybody to believe in it. So it's really quite a test of the scientific method, and the scientific method really has failed here.
Yeah, I wanted to raise something with you too, because I asked you this when I first emailed you, and that was about some of the other faculty members, the people you work with, and what, obviously they would know of your, I guess, side work, or, your theories and your, what do they say? Have any of them come around and sort of whispered in your ear and say, shit, mate, you're right?
So one fellow partially, basically agrees with me, although, he's not the type of fellow to go fully in to things. This is the one fellow, basically my supervisor, who I work most of all with on this space telescope project. Yeah, so, but he's not the type of fellow to get deeply that deeply into things. I mean, we discuss things, and we discuss things to the level that we recognize that we agree with each other, but it's basically left at that. But that's the only person. Generally, most everyone else is fully on board with the alarmist prognostications of this pseudoscience, as I like to call it. And yeah, they generally nobody will talk with me about it. They don't like to talk about it. One fellow has had the bravery to come and talk to me about it, and try to admonish me for my wrong thinking on this subject. And well, it didn't end well for him, but it was nice that somebody would actually come to try and challenge me, because I do like that and I appreciate that. But yeah, so most scientists won't discuss it with me in real life.
Yeah, it's a bit of a tell for me, really, too, when they're not forthcoming in debating or just discussing these things. I mean, there's censorship everywhere, isn't there? We don't need to go into COVID. But so, mate, do you want to show us whatever you think is pertinent to what you're doing?
Well, you sent me a list of questions.
Yeah.
So how about
let's go through them. Yeah. Look, so I'll ask the first one. So basically, have you? And I know the answer to this, but have you ever tried to put forward your model theory for peer review? And this is the global energy budget model.
Right. Yeah. So if you like, I can now show a couple slides so that people can see what we're talking about. Yeah. Right. All right. So here, I'll just share my screen. There we go. You guys should have me now.
Gotcha.
Okay, perfect. All right. So here's the foundation of climate science. This is the existing foundation of the pedagogy of how we begin to understand the climate. Yes. This is taught in classrooms. Here you can actually see a professor teaching this. I forget that David Archer is this fellow's name. I think he's a professor in geophysics or something. So he has the exact same diagram. You see these flat lines and these arrows. It's the exact same thing that I've pulled from these other universities. This one down here is a peer-reviewed, from a peer-reviewed publication from a very well-known climate alarmist scientist. So anyway, all these diagrams agree with each other. The same thing in my own undergraduate in second-year university, we have a course called planetary physics. I was taught the same thing. I thought nothing of it at the time, just went on. In any case, we look at what these diagrams are, and these diagrams are flat lines representing the entire Earth. And you think, well, no, there's nothing wrong with that. Well, what if there is something wrong with that? Is the Earth a flat surface? Basically, these diagrams say, let's treat the Earth as a flat surface. And from there, we will begin understanding and characterizing the basic features, the most basic features of the climate, such as a global energy budget. Well, it turns out that math and geometry and physics are all intimately related. So who would ever expect that, right? Would you expect that math and geometry and physics are all intimately related? Well, of course they are, right? Of course. So what happens when you treat the Earth as a flat plane? I mean, I'm not talking about treating a baseball diamond as a flat plane. We're talking about treating the entire surface of our Earth as a flat plane, the whole thing. Is there mathematical consequences to that that might generate some errors in your thinking about how the climate works and how the global energy budget works? And it turns out that, in fact, there are mathematical consequences. In physics, the consequences in geometry, I mean, let's talk about geometry here. Let's say in geometry you have a triangle and you represent the triangle as a circle. So how far are you going to get understanding that triangle?
Yeah, not far.
Not very far, okay? So in physics, in reality, we have the Earth, which is a sphere. But we're going to treat that sphere as a flat plane. So how's your math going to work out for understanding that sphere?
Complicated.
Good or not? Good or not good? Right? Not good, right?
Yeah.
That's a great analogy, actually, right? Let's use a circle to approximate a triangle to understand triangle. So anyway, it doesn't work out, right? It doesn't work out. So the mathematical consequence of doing that is that you spread sunlight over the entire surface area of the Earth at once as an input. That's what you have to do. If the Earth is a flat plane, well, then the sunlight input must be coming over that entire surface all at once because it's a flat plane facing the sun. So what happens when you do that, mathematically, the consequence is you dilute the heating power or the intensity of sunlight, because what you do is you spread sunlight, which is only coming over a sphere or half a sphere, a hemisphere. That's how sunlight actually comes into the Earth. But you spread it over the entire surface of the Earth. So you actually dilute it, you stretch it out. When you do that, you reduce its intensity. When you reduce the intensity of sunlight, you make it cooler. So that's what's happening in the model, in the numbers, in the mathematics, the mathematical consequence of that. You make sunlight cool. And in fact, you make it so cool that it's minus 18 degrees Celsius. And if sunlight is minus 18 degrees Celsius, well, that's not warm enough or strong enough to create the climate, the maximum temperature that the sunlight can generate on the Earth in these models. In this foundation of how climate science understands how the climate works is to say that the sun doesn't create the climate because the sun is only minus 18 degrees Celsius. That's what they say. That's the starting point. That's what's in these models. That is directly in there. So what I did is I came up with a different model, and I said, let's, for this global energy budget, and I said, let's depict the Earth as it actually is, a sphere with sunlight only intercepting a hemisphere at a time, and with the Earth rotating underneath that hemisphere, so that you have a day side and a night side. So now the solar intensity is as it actually exists on the planet. You're not artificially diluting it in your model to the nighttime so that there is no day and night. There's just a global uniform twilight. Now you have a day and a night, and you also have an intensity distribution where right under the equator, that's where the sun is the strongest, and of course to the poles it diminishes to zero until you get to the terminator. And when you treat the sunlight as it actually exists, as it actually comes in, well, then you find in the math and the physics that sunlight at the equator is 120 degrees Celsius. It's incredibly powerful. It's incredibly hot. When you have that level of energy coming in to the Earth, hitting the equator, well, that's certainly enough, 120 degrees Celsius. That's certainly enough energy, enough power to evaporate water and to generate the whole climate, basically. You know, and so in this model, you find, oh, wow, look at that. The sun has enough power to generate the whole climate. That's excellent. In climate science's foundation of understanding the climate, it says the sun does not have the power to create the climate. And so the question was, have you tried to put forward your model theory for peer review? So I did submit this for peer review to the American Meteorological Society, and I have, if you look here, my YouTube channel, youtube.com/climate of sophistry is my YouTube. This video right here, this one with the AMS logo, AMS official, their response to my diagram was to say that the sun does not create the Earth's weather or the Earth's climate. The response was the prevailing literature with our peer review publications, which I've shown you here. The prevailing literature of climate science is that the sun does not create the climate. Therefore, since your paper and model conflicts with the pre-existing literature, we can't publish it. So it wasn't about whether or not it made sense in terms of physics and geometry and mathematics. That didn't matter. Their concern was that the model conflicted with the pre-existing literature in climate science, which says that the sun does not create the climate. Therefore, we will not publish your paper. Go watch that video, and I read the reviewer's response where they say that very thing. Unbelievable, but it's documented, and that's what happened. So climate science begins its understanding of the climate with the proviso, or with the idea that the sun does not create the climate, and they do that because of flat Earth theory. Literally, it's as much of a pseudoscience as it is flat Earth theory. This is how you would develop flat Earth theory into modern physics, is you would do it through climate science. You would have the science of climate science. If anybody ever thought, hey, I want to develop flat Earth theory into a modern theory of physics, you would do that with precisely what climate science has done. So climate science is the pseudoscience of developing flat Earth theory into how it would have to work in modern physics. So that's what's happened.
And mate, I've watched that video, and interestingly enough, in case none of my family members do, one of the guys, one of the reviewers, was like, "Yeah, this seems good. Seems great.
That's right.
Good
Yeah, there
update.
was two. That's right. There were two reviewers. That's right. Yeah, and one said, yeah, that could, yeah, and he said, I don't need to see whatever editorial revisions. He said, go ahead and publish it. And then the other guy was like, no, that's
Yeah,
it. All
and,
conflicts with it.
and gave no justification whatsoever. It was just like
That's right.
it was ridiculous.
Yeah.
Can you just go over the flat Earth model there and
Yeah.
explain the 4 times you've got, because you know how you've got the sun coming in, but they divide it by 4.
Yeah. So that's the geometrical factor. That's the geometric factor to turn a sphere into a flat plane, basically. Basically, that's just yeah. So that's what that's for. It's because a sphere has 4 times the surface area of a disk of the same radius. So if you consider a radius and a disk of the same, a disk and a sphere of the same radius, then the sphere has an area which is 4 times that of the disk. So in order to turn the sphere into a flat plane disk, you have to divide by this factor of 4, as they do here in all of their flat Earth diagrams of the Earth, treating the Earth as a flat plane.
Yeah, no, that was an important one for me to understand. So I wanted to get that out. Yeah, that's So do you have the second question there, mate? Because I can't.
Yeah, absolutely. We can move on. Yeah, sure. We're still screen sharing. So here it is. So NASA says atmospheric carbon dioxide has never been at the level it currently is. Do you claim this is false? Well, here I have a little slide. So here's the historical example. This is a very common one that people almost always pull up. So carbon dioxide has varied widely. We are in current times in a state of carbon dioxide starvation in the atmosphere. If carbon dioxide had have went much lower than where it had been at the end of the 19th century, I mean, you start to approach the level of a global and permanent extinction level event where there's simply not enough photosynthesis carbon dioxide for photosynthesis function, because you need a certain concentration of carbon dioxide in the atmosphere for photosynthesis to function. And when you go below a certain level, which is not 0, it's a level that's 180, I think, or something like that, photosynthesis begins to stop. So that's the base of the food chain. So you stop the base of the food chain, you stop all life on Earth, basically. So the atmosphere is in a CO2 starvation state because CO2 has been sequestered and leached, and what's that term? In any case, leached out of the atmosphere. Carbon dioxide has been leached out of the atmosphere through geological processes and also from life. And so, yeah, so it's not at the highest level it's ever been. It's been much higher, and plants prefer it much higher. And in greenhouses, it's pumped to a level 5 times, 4 or 5 times the exterior open air level, because plants love that, and it makes plants grow really strongly, and they love it. So of course, yeah, that claim is false. If you agree, what could be the cause if it isn't man's influence? So the modern increase, well, the modern increase is still marginal. We're still at a marginal increase. So yes, it's increased, but it's still a marginal total concentration compared to what it could be, and compared to what we do in greenhouses, and compared to the geologic past. It's a marginal increase. It's very small. And that increase, I believe, started occurring well before the Industrial Revolution even. So it might not even be due to man. If it is due to man, this is actually a wonderful thing, because you know what this is? Watch the movie The Lion King. It's the circle of life. Oil companies are completing the circle of life, basically, right? We are, by burning fossil fuels, if you want to call them fossil fuels. Hydrocarbon energy, we're replenishing the atmosphere with fertilizer. We're replenishing the atmosphere with the basis of life, carbon dioxide. It's very good for the environment that we're doing this, because the Earth would have just basically come to a standstill in the next few million years, and then that would have been it for Earth, because it would have ran out of carbon dioxide in the atmosphere. So we're pumping it back in. Possibly it's from us, maybe not. Maybe it's the Earth doing it itself through geological processes that maybe we don't understand yet, or just through natural geologic processes like volcanoes and whatnot. In any case, it's quite good for the atmospheric carbon dioxide concentration to be pumping up. That's quite excellent.
Yeah, great.
Right. So question 3, want to move on? Yeah.
Yeah, definitely, mate. Yeah.
Okay, good. So if there is no greenhouse effect, how do you explain the rise in temperature when the solar irradiance has dropped comparatively? Well, I think the solar irradiance, I think the change is again quite marginal. And again, the rise in temperature began at the end of the Little Ice Age in 1850. That's when the rise in temperature began. So, so man certainly didn't do that. We weren't emitting very much carbon dioxide in industry at all yet. Then, not until the mid 20th century were we doing that, and even towards the later, towards the latter half of the 20th century, did we actually start emitting very much noticeably. So the temperature increase began well before human emissions of carbon dioxide. So it seems to be a natural process. Of course, it was a cold period, the Little Ice Age. So what happens after a Little Ice Age? Well, then it warms up. So that's all that's happened.
Great.
You want to continue then?
Yeah, let's keep going, mate. You're on a roll.
Okay. All right. So irrespective of man's influence or not, wouldn't we all benefit from being cautious and adopting stricter carbon pollution measures? Well, carbon isn't pollution. It's plant food. It's the basis of the food chain in photosynthesis, and the atmosphere, the biosphere is starved of it because the atmosphere is such a low concentration of it from the ravages of geological history having leached out all the carbon dioxide. So carbon dioxide isn't a pollution, isn't a pollutant. And this idea is called the precautionary principle, where you do something just in case because you're not sure. Well, in this case, we can be sure, okay? But even if you couldn't be sure, let's ask Mr. Atheist. The precautionary principle question, a statement such as this comes from religion, and it goes to the effect that you better. So if there's any atheists watching, right? So you better not be an atheist, and you better believe in Jesus, because your life is very short, 60 or 70 years. But if you don't believe in Jesus, you're going to hell for eternity. And so that's a pretty big thing to worry about, right? You get a short 60-year life, but you're going to spend 1 trillion years in hell if you don't believe in Jesus, right? And they say, well, there's no evidence for that. Yes, well, in fact, there's no evidence for climate change alarmism either. You've only been told that there is, just like you've been told that you better believe in Jesus or else you're going to hell, right? It's the exact same thing. So if there's any atheist, but then how is an atheist going to handle that, right? Because then you better say, well, I better not just believe in one religion, I better believe in them all, because they all have something or other to do with the salvation of the soul, right? So you better believe in them all. Oh, but then they're all conflictory, right? Conflicting. So what do you do? So no, it's a totally specious argument. Imagine if you ran your life that way.
Yeah.
I mean, look, so they can come up with an argument like this, the precautionary principle argument based on flat earth theory. So what aren't you going to be able to be convinced to be afraid of and then adopt and do? If you'll do this for flat earth theory, if you'll adopt the precautionary principle and call carbon dioxide a pollutant that you need to get rid of for the sake of flat earth theory, then what aren't you willing to do? I mean, you can just be sold down the river completely. I mean, you have no discriminatory, rational thinking ability in your mind whatsoever at that point, do you? I mean, it's quite disturbing. I mean, let's just believe in, well, anyway, you get the point, yeah?
Yeah. But it's a big one for people, because they've been just, I guess, from probably day dot, especially the younger ones, it's been drilled into them that, carbon dioxide's a pollutant. And so
yeah, it's been bombarded through the media and what. Yeah, absolutely. Yeah. I mean, people love it. I don't know what it is psychologically. I mean, you really have to analyze. This isn't a problem of science. This is a psychological problem. Someday somebody is going to have to figure out what the psychological problem is of humanity that we would believe in something like this and adopt it. And I mean, there are some indications. I mean, there's this idea of original sin, which is very widely adopted in humanity. This directly goes to that. You breathe carbon dioxide. Our industry creates carbon dioxide. This is a pollutant. This is sinful. So somehow there's some sort of psychological hijack happening there, even among the atheists, because although you may be an atheist, somehow you still have within your mind space, or it's in the shared collective archetypal subconscious, this concept, this archetype of original sin. And so as an atheist, you've simply moved it from original sin to sin for existing and in emitting carbon dioxide. So psychologically, that's what's happened as a trick. Your mind has been hijacked without you knowing it. Yeah, it's very rich psychologically. This isn't a scientific problem; it's a psychological problem.
Interesting. Yeah, I'm not sure about the. I mean, we all grew up Catholic in this chat. I'm not sure if any of them still are practicing, but I'm certainly not a practicing Catholic, and I don't subscribe to the word of the Bible. But of course, life is a mystery, so I'm sure there's something out there, right?
Sure, right, yeah.
But mate, yeah, please go on.
All right, sure. So in your opinion, what are the strongest arguments that climate alarmists put forth? And do you think that there is any logic in them at all? I would have to say I know of no climate alarmist. I mean, I've gone to the very basis here and found that the basis is flat earth theory. So nothing following that, your poster behind you, right?
Yeah,
it's your poster behind you. That's the state that we're in. That's where we find ourselves in.
I might just sort of show everyone that, just so, because we brought it up. But I like that poster. If you don't start with the truth, everything that follows will be a lie.
Yeah. So we're starting with flat earth theory and developing a science based on flat earth theory. So basically the entire thing is incorrect. The lie. I mean, on one level, it would be an innocent mistake, but on another, where it's so obvious and where you see the political influence and whatnot's been attempted with it, it's obviously some sort of purposeful thing going on here.
Cool.
Right. So might as well go to question 6 then.
Yeah, mate. Let's do it.
So have you publicly debated with any experts who disagree with you? Are you willing to? Yes, certainly I'm willing to. Are they willing to? No, they're not at all. I have discussed this with a couple of people. I do have one video where I did discuss it with somebody who was knowledgeable. I'm not sure who the fellow was, but this video is called "This Is Why They Won't Debate Me." So it's the second 2 videos after the AMS official video. So this is why they won't debate me. So that's a video you can watch and listen to where I debate somebody who seems to be a knowledgeable expert in the field, and basically I eviscerate them. And
I've heard that one. Yeah,
absolutely. Yeah, that's right. Trounce them. So yeah, so there's that. But yeah, as far as let's go back to where were we? Yeah, so no, they won't really debate me on it. I have had internet dealings, because obviously you can have message boards and you talk with people, and really you just get the most insane things. There's this one well-known fellow, what's his name? Oh yeah, Roy Spencer, who passes himself off as a skeptic, but he still supports the very basis of the science, this idea of a greenhouse effect. I should go back, actually. I'll go back and explain how the greenhouse effect comes in, actually. So anyway, he supports this idea of a greenhouse effect, which I point out, is flawed because it's based on flat earth theory. And, his very strange response was to say, nobody believes in flat earth theory. We don't think that the earth is flat. All that we do is we spread sunshine, incoming sunshine, over the entire surface of the earth as if it's a flat plane. That's not believing in flat earth theory. It's like, okay, it's not believing in a flat earth theory, yet it is functionally flat earth theory because you're doing what you just said, right?
Yeah.
He's like, don't be so ridiculous and call us flat earth theorists. We're not flat earth theorists. All we do is take the sunshine and spread it over the entire surface of the earth as if it's a flat plane. And I'm like, that's exactly what I'm saying is wrong. Don't call us flat earthers for it, but it is flat earth theory, right? So that's the extent of debate that they're willing to engage in. And so what does that tell you? It tells you something, doesn't it?
Yeah. Well, yeah, to me, it says a lot when someone is not willing to back up their ideas and claims against someone else. I mean, I can understand if someone's not a great orator and public speaker, etc., but you can at least have correspondence. you know, over email or wherever. And when they're not, if no one's out there willing to do this, with honestly, you know, I email all sorts of scientists who believe in global, and they never get back to me. The only ones that have ever got back to me are people like yourself. And you know, everyone's busy, right? That's a big tell for me. But anyway, yeah, you were going to go back to and explain the greenhouse effect.
Yeah, so this was important because, you know, when we have this foundation, as I explained it earlier, where they're diluting sunshine down to a value of minus 18 degrees Celsius, so now the sun can't create the climate. So the greenhouse effect then is then postulated. That's where it comes in. And it's the greenhouse effect in the atmosphere, which then generates all of the higher temperatures and the climate. Because imagine minus 18 degrees Celsius, imagine minus 18 degrees Celsius in your freezer. You put a pot of warm water in your freezer, if your freezer is all the way down to minus 18 degrees Celsius, well, not much climate is going to be happening in there. That water is just going to freeze and nothing's happened. Well, it's going to happen. Well, so to explain what's happening on the earth, you need some other mechanism to generate the higher temperatures to keep that water melted and also evaporating. And so that's what the greenhouse effect does. And this greenhouse effect that they've invented for climate science isn't actually how an actual real greenhouse functions. So you can see that there's a very convenient play on words there, because they use this term greenhouse effect to bump up the temperature, to explain higher temperatures than what the sun can produce, and to explain the climate that in their model the sun can't produce. But it's not how an actual real physical greenhouse functions. A real actual physical greenhouse functions completely differently. So you see how that's convenient, because everybody understands a physical building greenhouse and that it's warm. And so if they're just saying, oh, well, that's what the atmosphere is doing. And it's like, no, the atmosphere doesn't actually do that, because the open atmosphere can't do that, because a greenhouse building stops the atmosphere from convecting, stops the open atmosphere from allowing warm air to rise away and then to be replaced by cooler air. So a real physical greenhouse building stops that process, right? So they're not the same thing at all. It's just a convenient sort of play on words, very convenient, in fact, right? So their greenhouse effect is this idea that that radiation can bump up its own temperature, and the point is they need to postulate this radiative greenhouse effect in the atmosphere in the first place, because they've treated the earth as flat, which makes sunshine too weak to create the climate. So then they postulate this greenhouse effect, right? So that's what's happened. That's what their greenhouse effect is. Whereas if you do what I show, treat the earth as a sphere, place sunlight only where it actually exists. Oh, wow, now your geometry and your mathematics matches reality. Isn't that nice, right? So that's great. And then now you find that the sun creates the climate. Well, gee, that's important, isn't it? Well, not to them, because it conflicts with the prevailing literature. And so that's what peer review gets you. Peer review gets you protection of the prevailing literature, even if the prevailing literature has been tricked into being flat earth theory, where the sun doesn't create the climate. It's really amazing. In addition to this being a psychological problem, it is one of science. It really is a statement of the problem of the scientific method and its validity. And obviously we found a major problem here, haven't we?
Yeah.
And so there's going to have to be some sort of reconciliation of these facts. And hopefully we survive to get there, because a consequence of their flat earth theory is that governments are now burying the air under the ground, because climate science, flat earth theory, climate science says that this is a good thing to do for the environment, is that we should use government level resources to bury the air under the ground. So that's a consequence. And it's not just the air, it's the specific part of the air that makes plants grow.
Yeah.
So to help the environment, flat earth climate science says we should bury the part of the air that makes plants grow under the ground. So we're kind of in a comical, ridiculous situation here. And if you take that to its limit, I mean, these people are calling carbon dioxide a pollutant. Well, what do you do with a pollutant? You get rid of it. Well, if you get rid of carbon dioxide, you get rid of the basis of the food chain, and you get rid of all life. It's totally psychotic. And what do you expect as a result from flat earth theory? Because flat earth theory is psychotic. So there you go.
Yeah, I personally agree. Can you go over one technical aspect that I think will make it easier for people to understand about this greenhouse effect, where I think it's the first or second law of thermodynamics, where a cooler body can't reflect heat down to, to a warmer body. Because you explained that well, and I think that.
Yeah, so I do have quite a few videos on that topic, so people could check that out. But yeah, I mean, it's a basic. I don't have the equations pulled up here, but anyways, yeah. Anyway, the basic equations in thermodynamics are that in regards to temperature, how do you increase temperature? So how do you increase the temperature? What's the physics, which is always depicted with mathematics, explained or shown with mathematical laws? How do you increase temperature? How is it done? Well, you increase temperature with something called heat. You can also do it with work. Generally, we're not dealing with work in terms of the climate, but temperature increase due to work would be, for example, your bicycle tire warming up when you pump it up, when you pump air in. So that's work being done, which causes a temperature increase of your bicycle tire. We don't need to worry about that in terms of the climate science greenhouse effect, because that's not what's happening. What's happening is would have to be heat. So what is heat then? It's very important then to understand what heat is. So take an ice cube from your freezer and hold it in your hand. Is that ice cube transferring heat to your hand?
No.
No, it's your hand transferring heat to the ice cube, right? So a very important thing in thermodynamics is that heat flow is irreversible and it's one way. It's from the warm object to the cold object only. So in the climate science scheme, what they have done is they have had to say that in order for their greenhouse effect to work, that heat must be recycled from the atmosphere, which is cooler than the surface, but it must be recycled and come back to the surface and warm the surface up some more to bump it up to the temperatures that we actually observe, since in their thinking the sun is only minus 18 degrees Celsius. So that scheme requires the energy that's in the atmosphere, the thermal energy that's in the atmosphere, to act as heat for the surface, because heat is what is required to increase temperature. So if the atmosphere, with its energetic radiation, is increasing the temperature of the surface, that can only be done if that radiation, if that energy was acting as heat. But however, the laws of thermodynamics are such that heat cannot flow from the colder atmosphere to the warmer surface. In fact, what happens is that in reality, the solar input is very high temperature, very high heat levels, 121 degrees Celsius. That heats the surface. Then that heat transmits into the cooler atmosphere, because heat is flowing from the warm surface to the cooler atmosphere. And that process generates your climate, keeps water liquid, generates evaporation, all sorts of stuff like that, right? With heat flow as it's supposed to occur, hot to cool. In their scheme, of course, as I just said, heat has to recycle. Heat has to travel from cold to hot, and it's simply strictly impossible. Yeah. The first law and second law of thermodynamics, are all about that. What heat is and how it can behave. It certainly cannot be recycled, cannot flow from cold to hot. And that's precisely what climate science is predicated on, fundamental violations of the laws of thermodynamics. And why wouldn't you find, in fact, if you look at the science of climate alarmism, you find fundamental contradictions to physics and science everywhere. It's everywhere. But of course, why would you find that? Well, it's like that poster behind you, because you're starting with a fundamentally flawed premise. The very starting point is flat earth theory. So what physics are you going to develop after that? Everything you develop after that is going to be found to be conflicting with some aspect of physics or another. I have a few videos on that, actually. If you do this, you can actually extrapolate what the distance of the sun to the earth must be, right? If you use their math. If this depicts reality, well, in fact, there's a mathematical equations and tricks from astronomy you can use to then calculate what the distance is from the sun to the earth. So here's an example, and you come out with a factor of 2 times more. The sun should be 2 times further than it actually is. So anyway, it's just another example of how you just come up with myriad errors. Yeah, here, this one, climate change denial of Earth's orbit, astrophysics. Yeah, that was that video.
Mate, that's great. Yeah, it makes it very clear when you explain like that. And thanks for, your time and answering all those questions, and yeah, hopefully the family chat will be a buzz with debate and disagreement, and maybe
Right, yeah.
maybe they've learned something. Who knows? But
Sure, yeah.
mate, I thank you for your time. Did you want to say anything else, or you got any views on COVID?
It's part and parcel of the whole thing.
Yeah.
You know, it's the same people, you know, because now they're trying to tie COVID and climate change together. So it's the same people. I mean, there's regular scientists out there like me. Most scientists stay quiet and just do their job. A very, very few number of scientists are like me and will say anything. And then obviously we get the whole treatment from the system, which is quite unpleasant, you know. But as far as that, it's the same people, and you can't trust these people. Do not don't trust anything they're telling you or that you should do, especially you don't take their drugs and their poisons, you know.
It certainly seems to be the same kind of play that they're making and creating.
Yeah.
But yeah, we won't go in there. Mate, I thank you for your time again, and you know, I look forward to our correspondence in the future, and you know, maybe hopefully, you know, we can do this again, and if we got a chance to, and a reason, and that'd be great. But
Sure, yeah. Well, it was nice to meet you there, Johnny.
yes, nice to meet you again, and we'll speak soon, mate.
Okay, sounds good. Take care.